Let's review what we know about moles. We know that 1 mole of a substance equals the molecular mass of that substance. So we can always use a conversion factor where we look up the molecular mass of something. So for example, 1 mole of CH4, if we look up carbon on the periodic table, we see it has a mass of 12 grams. And if we look up hydrogen, we see it has a mass of 1 gram. And multiply that by 4. This is 12 grams per mole and 1 gram per mole. And so altogether 1 mole of CH4 or methane has 12 grams plus 4 grams or 16 grams. And so I can use this as a conversion factor for CH4. So if I need to find out how many grams are in 48 moles. No, that's too many. I don't want to multiply that. I don't want to get out a calculator. How many grams are in 2.2 moles of CH4? So I start with 2.2 moles of CH4, and I'm trying to get to grams, so I'll put 1 mole on bottom. And remember, it's always going to be 1 mole when you're doing this kind of conversion. And on top, 16 grams, and then 35.2 grams CH4. Okay, so that is converting from moles to grams. If I needed to do grams to moles, I just set it up, do the same thing, just I'll have my conversion factor upside down. How many moles of carbon dioxide are in 88 grams of carbon dioxide. So I'll start with 88 grams of carbon dioxide, and then I want to cancel out grams, so I'll put that on bottom, put mole on top. Look up carbon on the periodic table. Carbon is 12, and I have 1 of them. I look up oxygen, it's 16, and I have 2 of them. So that's 12 plus 32 is 44 grams. So there are in 1 mole, remember that's always 1 mole, there are 44 grams of CO2. And so 88 divided by 44 mole CO2, which is 2 mole CO2. And so that is grams to moles. Okay, now we also have the relationship that our chemical formula tells us something about how many atoms are in each molecule. So, how many hydrogen atoms are in 1 molecule of C2H6? And the answer is 6. And then how many carbon atoms? And the answer is 2. And then we can use that to extend our information about the amount. If I have, it doesn't just have to be one molecule, it could be moles, because moles are what we would use to deal with, an actual quantity of something that we could measure. So I might ask the question, how many moles of chloride ions are in 3.2 moles of magnesium chloride. So you start with the number you're given, 3.2 moles magnesium chloride, times, and then I want to cancel out moles of magnesium chloride, so I'll put 1 mole of magnesium chloride. And then in 1 mole of magnesium chloride are 2 moles of chloride ions. So it's 2 from that right there. So it'd be 6.4 moles chloride ions. How many moles of sulfur, we're going to do oxygen atoms are in 2.6 mole of aluminum carbonate. Okay, so you start with the number you're given, 2.6 mole aluminum carbonate, times in 1 mole of aluminum carbonate, how many oxygens are there? So I'm going to pause for just a second while you think of what the answer should be. And the answer is 9. 9 moles oxygen atoms, because you're going to always multiply these subscripts. So you multiply those. So this is 2.6 times 9. So that's 23.4 moles of oxygen atoms. Alright, so there's another conversion factor that we can have. So we have that 1 mole equals the molecular mass in grams, so we can always use that. And then we also have that 1 mole of the compound equals the number, let's see, I'm not quite sure how to write this conversion factor, is the one that we were just doing. This is where we would make the conversion and we would say 1 mole of C6H12O6 is equal to 6 moles of oxygen atoms. So we have that conversion factor. So this is where we're converting between mole, molecule to mole, atom. And to do that, you use the subscripts. Then we also have that 1 mole equals 6.02 times 10 to the 23rd items, whatever it is. So that's just a number, that's Avogadro's number. And so I can now do just however many conversion factors I need to get to what I want to cancel out. So if I were to ask how many chloride ions are in 2.6 moles of sodium chloride. So I start with my 2.6 mole of sodium chloride, and I need to get to number of chloride ions. So whenever it says how many, that's going to be your number, and that's going to use Avogadro's number, which the symbol for that is Ma. Ma is Avogadro's number. So start with the number you're given, 2.6 moles NaCl. I need to get to chloride ions. So I need to get from moles of sodium chloride to moles of chloride. And so I'd have that 1 mole of sodium chloride is equal to 1 mole of Cl, because the subscript is 1. And then 1 mole of chloride ions is equal to 6.02 times 10 to the 23rd chloride ions. And that is 1.57 times 10 to the 24 chloride ions. Now you always have to go through moles. I'm just going to leave it like that. Always go through moles. So you cannot go from grams of something to grams of something else without going through moles. So you always have to change, you always have to get moles of an item before you can get something else from it. So if you're given grams, you have to go to moles first. If you're given a number of atoms, you have to go to moles first. So before you can change to anything else, you have to change to moles. So if I had the question, how many oxygen atoms are in 64 grams of O2 gas. Okay. You always start with what you're given. 64 grams of oxygen gas. 64 grams O2 gas. Now, what I just said right here is you always have to go through moles. So to change from grams to moles, you use the molecular weight. So 1 mole of O2, you look up oxygen on the periodic table, it's 16, so O2 is 32. 32 grams of O2. Okay, so now I have moles of O2, but I need to have moles of oxygen atoms, not moles of these oxygen molecules. And so I'll say 1 mole of O2, because I need to cancel moles of O2. 1 mole of O2 is 2 moles of oxygen atoms. Whoops, just oxygen atoms. So now moles of O2 would cancel. I have moles of oxygen atoms. Now I need to get to the number of oxygen atoms, and so I know that 1 mole of anything, or 1 mole of oxygen atoms, is 6.02 times 10 to the 23rd oxygen atoms. And moles of oxygen atoms cancel, and I have the number of oxygen atoms. So I would have 64 times 2 times 6.02 second EE 10 to the 23rd. And then I have 32 in the denominator over 32 is 2.408 times 10 was up to the 24th, 10 to the 24th oxygen atoms.